Okay, in this next example here, I want to talk about parallel arrays, and the easiest way to illustrate this is just via an example. So I'm just going to run this program first to show you what it does. This is array2.sb right here, and the way it works is you tell it how many grades you want to enter, and I'll keep it simple here. Tim has a 30, Joe has a 80, Louise has a 50, right? And you've already seen the average test score and the highest test score and lowest, but the new thing is search for a student, and also the changes come into the highest and lowest scores. So let me show you what I mean. First of all, if I do search for a student, say I want to search for Louise there. So I hit 4 for the menu, and then I type in the name of the student. And then it tells me the score of the student. Well, their name and their score. You can see here's this name and here's the score. The average is the same, but if I look at the highest test score, it tells me it belongs to Joe, and it's 80. And if I do the lowest, it tells me it's Tim, and it's 30. So this is an enhancement in the sense that it tracks the name of the student along with the score. And then also the fact that you can search for students, or a particular student anyway. Now, it's not as robust as it could be, because you could have two students with the same name, and you could have situations where there's a conflict. Maybe there's a tie on the high score, or another thing could happen is you could put a lowercase name for a student. So there's things like that that we could do to enhance it, but the point that I'm trying to make with arrays, we'll get that across just the way it's written now. So I'm just going to, instead of continue to add to it and make it more complicated, just show it to you the way it is. So this is the program, and you can see the in the comment up top here, it's updated to describe the fact that we have parallel arrays, and we're going to show the student's name along with the value for their grade. And at the start of the program, notice I put a comment here in the end here. Now I do that just so that I know where it obviously starts and stops. And these are just calls to subroutines. All the subroutines below it are just called. And so technically the program ends here on line 13, but all the work is done below that. So get the number of test scores is the same as it was before. You just ask the user, they enter a number, it validates it, and that's it. Get all test scores is here, and that hasn't changed either. The score that's entered is checked for validity, but when you call the subroutine to get a specific test score, which is get a test score, which is right here, you're asked to enter the name of the student. And notice I have two arrays now, a names and a scores. Notice the way I named them. I used the plural case, which is appropriate because there are more than one name. There is more than one name in the array, as well as the scores. The index is coming from the loop that this gets called out of, and you're reading in the name into one array and the score into another array. So knowing that, going back up to get all test scores, then this loop gets a test score and a student name, both from this method call. If the score ends up not being valid, it re-asks for both the name and the score. Now, that's something you could fix also or improve on, but if they type in a name and they type in a score that's out of range, it's going to call the same subroutine get a test score again, and it will ask them for the score and the name. So I figure that's probably not that big of a deal. If they messed up on the test score, it's not that big a deal to ask them to enter the name a second time. Anyway, so this gets all the test scores and names. I suppose I could rename this method so that it said, get all student data and get student data. I could probably name these because score is fine, but we're actually asking for more than that now. We're getting a name and a score. But I'll leave it the way it is because, again, I didn't want to get too carried away here. So display, okay, let me go back to the top. Display menu gets called last, and that takes you down to here. So we've got the scores and the names and the arrays that we needed to. Now we display the menu. Additional item here, number 4, search for a student. Exit the program now becomes a 5. You make your choice. If it's less than 1 or greater than 5, you're asked to repeat that. Otherwise, it evaluates the choice, 1, 2, 3, 4, and if it's any of those, it displays the menu again, recursively calling the same subroutine. Otherwise, it does nothing, in which will terminate the program. So that didn't change either. So high value and low value in search for student are different. So let's take a look at those. The display high value subroutine, in addition to storing the highest score, I also store the highest name. So the only thing, if you look at the difference between example 1 and example 2, every time I set the high score, I also set a high name. So that happens on lines 45 and 6, and it also happens on lines 49 and 50. When you hit 53, I display the highest name and the highest score to the user. Do the exact same thing for low value. I store the name and the score whenever I'm storing them, and then I display them both. Search for student is new, and what I'm doing here, first off, if the user types a name for a student and I go looking for it, and I need to know if I found the student or I didn't find it. So I created a variable on line 69 here called found index, and I set it to -1, which is an invalid value. The thinking here is that if I ask the user for a name and they type one in for me, which I store here in the name variable, and I go through this loop and I can't find a match. By the time I hit line 78, if found index is not greater than 0, then I tell them, sorry, a student wasn't found with that name. If the found index is greater than 0, then I found something, and then I display the name and the score of the student that was located. Notice I go into names and I go into scores, these arrays here, and I index them by this found index variable. Now, found index is set inside of this loop right here. And the way it works is you ask the user to enter a name, they enter it, it gets stored in this name variable. I go into the loop through all the items in the names array, or it could have also been scores. They're both the same size. So I starts at 1, it goes to the length of either array. Here's where the main core of this procedure is located, right here, line 73. If the name the user entered equals the element in names at position I, if they match, then I take the value I, which is the current looping variable, and I set that into found index, because that is telling me that wherever I is, say I is equal to 5, right? That means the 5th element in my array, we found a match. I need to take that number 5, which is in I, and store it into found index. So now found index is going to equal 5. That way when I come down to line 78, found index will be greater than 0, and it will go into names with the 5 and the scores with the 5 and give me the right student and their score. But once I find a match, I don't want to keep looping through the students. So what I do on line 75 is I purposely set I equal to the length of the array plus 1. You should never generally change I. I is a variable that the loop adjusts as it goes on its own, implicitly. What I'm doing in line 75 is generally a bad practice, but in this case, I'm purposely setting I out of bounds of the loop, so that when it comes back up to line 72, I is greater than the upper limit of the loop. So it falls out and goes down to line 78. So it's a way of breaking out of the loop, essentially. That's how I'm doing that. We set this index invalid. We ask for a name. We search. If nothing is found, the index will still be invalid, and we tell them they're out of luck. Or they type in a name, we go into the loop, we find one, we set I out of bounds, breaking us out of the loop. Meanwhile, found index will have been set to the correct index of the array that has the name in it that matches the correct element. We take that index pointing to the correct element. We reference the names array and the scores array. Now, both arrays are in sync with each other, or they're in parallel. And I drew this in the last video, but if you have a 50, a 30, and a 60 for your scores, and R is Roger, G is George, W is Walt, okay? And I search for George. When I find George, he's going to be at position 2. So found index will be set to 2. When I write out student name equals, I go into the names array, which is the lower one, and I go to position 2, and I see George and display his name. Then I go to the other array in the same position. They're lined up here by column, and the second column has George in it. Here's his name, here's his score. And I could have created 3 or 4 different arrays, and they could all be in parallel with each other. So for instance, I could have put another array in here, which might have his GPA, 4.5, whatever. And so if I found George, I could say, okay, I'm going to look to this array for his score, and this one down here for his GPA. In this case, I would have 3 arrays all in parallel with one another. So that's the idea behind it, the concept of a parallel array. It enables you to store more than one set of data and link them all together on a common index. And that's basically what's happening here. So this example, I'll also put out for you all to look at. And we could talk a lot more about arrays, and the book gets into some more things related to multidimensional arrays and such, but I think if you can understand this much about arrays in this course, you'll be in good shape for whatever you're going to be taking next. So take a look at these 2 examples. The video's in 2 parts this week. Watch both parts. If you haven't seen the first one yet, go ahead and watch that one first. And anyway, this will help you get off the ground on your assignment. It's very similar to what you're doing here. And that's it. I'm going to wrap things up here. So if you all have any questions, let me know. Otherwise, good luck on your homework. And this is the last week of the semester. So if you haven't completed that student survey yet that the school had asked you to complete, please do that if you would. And I'll be along later in the week to guide you as far as wrapping things up for the semester.